Hello my friends and welcome to this new practical section. We are still in level 1. In the previous practical section we tackled regression with the linear regression model, and now in this new practical section we're going to tackle classification with a new machine learning model, which is logistic regression. And we're going to implement this for a new real-world case study, meaning a new data set, which will still be very simple because we are in level 1, but you will see that we will have one additional thing to do in data preprocessing that is very important. Alright, so let's go into our classification folder and let's open our logistic regression implementation file in a Google Collaboratory file. Alright, so I remind that this file will be in read-only mode, therefore we cannot do any modifications on this, and therefore we're going to create a copy of this file so that we can redo the whole implementation together, because that's the best way to learning by doing. Alright, so here click Save a Copy in Drive. This will be creating a copy, there you go, on which we will be able to recode everything together. Alright, but the first thing, remember, is to delete all the code cells, try to not look at them, and make sure to keep the text cells, right, to keep the structure. So here I'm only removing the code cells, right? Okay, so here we remove this, then this, and this, and almost done. And here we go. All right, so now let me present to you the structure of this implementation. It's always good to understand, to take a step back and understand how we will structure our implementation. So, first of all, the structure is still in 3 parts. Part 1, data preprocessing, Part 2, building and training the model, and Part 3, evaluating the model. That's the main machine learning pipeline or machine learning process in those 3 parts. Then in the higher levels, we will add some hyperparameter tuning, to tune our model and improve its performance. But this is the base. This is the fundamental and compulsory parts you must go through when implementing a machine learning model. Now, in part 1, data preprocessing, we will start by importing the dataset, of course, then getting the input and output, then creating the training set and test set, and that's the new thing we have to do here in this implementation, we have to do feature scaling. And the reason for this is that feature scaling must be applied for any gradient descent based algorithms, and logistic regression is one of them, right? Another example is all the neural networks algorithms, which we will do in level 3. But you have to remember that for any gradient descent based algorithm, you have to apply feature scaling. Now you have to know this $1 million question that exists online. You will see it in the forums. Does feature scaling need to be applied before creating the training set and test set, or after? And the answer to this is after. And that's because when you create the training set and the test set, well, the test set is supposed to be new observations on which the model was not trained. It has no idea of the ground truth for these observations in a test set. And therefore, since when performing feature scaling, we will have to get the average value and the standard deviation of each feature, well, those average values and standard deviation should be calculated based on the training set and not the whole data set, right? Because in the whole data set, there will be the test set, and the test set is supposed to be new observations on which the model is not trained. So the feature scaling must be applied to the training set and not the whole data set. And so you see, it's very important to apply feature scaling after the split of the data set into the training set and the test set. All right, so we will do this new data preprocessing step together, and then in part 2, it's going to be almost the same. We will first build the model, train the model, and then once we have a trained model, we will proceed to the inference mode, where we'll make the same 2 types of predictions, the predictions on the test set and a single prediction, based on a single observation. And then in part 3, we will evaluate the performance of our model with 2 tools, first the confusion matrix and then the accuracy, which are the relevant metrics when evaluating a classification model. All right, so are you ready to start the implementation? But first, let's of course upload our data for this case study, and I will quickly introduce it to you. So here you click this folder button here, then this upload button, and then remember you go to your codes and datasets folder that was provided to you in this course. Then you go to level 1 and then classification, and there you go. That's the data you need to upload for this implementation. You click OK here, and now because it is a CSV file, we can actually double click on it and already have a look at it. And so let me actually enlarge this. There you go. And so this is a data set of the machine learning UCI repository in which each row represents a patient, from different hospitals, where they collected for each of these patients several features of their breast, like the clump thickness, the uniformity of cell size, the uniformity of cell shape. I'm not an expert in medicine, so I couldn't explain to you what they mean exactly, but there you go. These are features of patient's breast. And so all these features here are the independent variables, and same for each of these patients, we have the dependent variable which tells if the patient has a benign breast cancer tumor or malignant. If the class is 2, that means that the tumor is benign, and if the class is 4, that means that the tumor is malignant. And so we're going to build a logistic regression model that will learn and understand the correlations between all these independent variables and the dependent variable, meaning the class, telling whether the tumor is benign or malignant. All right? And so if you're ready, let's close the data here. We will then import it in the next step. So I look forward to starting this implementation with you. And until then, enjoy machine learning.